Hello, and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buteau, president of the PCEA. Today's guest is Matthias Wagner, chief executive and co-founder of Flux. Flux is a maker of a browser-based PCB design platform and programmable simulator. We spoke with Matthias last spring as the company was introducing Flux Copilot, an AI-powered hardware design assistant. Flux Copilot uses a large language model that the company's engineers trained and integrated into its design tool. Today, we're going to talk about the advances and the real use cases Flux is seeing. Welcome back to PCB Chat, Matthias.
Hi, Mike. Thanks for having me back. It's been a minute.
So it's been almost a year. Why don't we start by you giving us an update on Flux and where you're at? And I know that while a lot of big name companies are laying off developers, it looks like you're still hiring.
Oh, yeah. I mean, we're growing. We're always hiring.
Always hiring.
I'm happy to... always hiring. I once heard a quote like always recruiting, not always hiring. But no, we're always hiring. Yeah. Last time I was on here in April, we had just launched last year in February a V1 of Flux into the public. And it's been really exciting, right? So it's been like a year now since we launched. AI Copilot was launched last year in April, so that's like just 10 months. It feels like 10 years now, but it's only been 10 months. It's been really exciting. So we've grown to 40,000, engineers on the platform every month, which is a huge number, right? It was like before we launched, it was maybe 200. So we've seen massive growth here. And then a lot of exciting developments around the usage of AI, right? If you remember last April when we last talked, we came out with like an AI chat agent, right? That was optimized for use cases around schematic and PCB layout and bill of materials. And we've since evolved that dramatically, right? I mean, users can today, right, customize the information that the agent leverages, for example. We have like more, dialed in use cases, like, for example, what's coming out now, the ability to automatically turn datasheet PDFs into parts in Flux, right? So it creates a symbol for you, the footprint, the 3D model, gets all the metadata. It can even get all the associative metadata. Let's say you want to know the materials used in the semiconductor, right? For your compliance reasons, you can get that automatically. And so we've come really a long, long way. And then pile up on that, other great use cases like, schematic design reviews, right? Faster design iteration because Copilot can connect components in your schematic for you, right? You can do like BOM research, replacement research, right? Supply chain optimization with AI Pilot. So there's a huge swath of use cases that we're together, discovered with users and have further doubled down on.
40,000 users per month. That's a lot.
Every month. Yeah.
Do you have a sense of where people are coming from?
Yeah, absolutely. I mean, majority of them is from North America, United States, a lot of Europeans, a lot of people from South America, a lot of people from India, right? I mean, all these like major electronics hubs, if you will, are present on the platform. The other exciting, thing has been that we've seen a lot of companies in the ecosystem come onto the platform. A lot of semiconductor manufacturers, right? We have like Raspberry Pi here, Seed. Word is going to come on the platform. We have a partnership now with Auto Librarian. We're getting all their partners onto the platform now, with the symbols and footprints. And so Flux is becoming this this massive global community here where semiconductor manufacturers and users alike are coming together to build faster and build better. Remove the friction. I think a lot of semiconductor manufacturers, if you think about them, right, they're trying to digitize their business. And the design tool is the point of sale. That is where ultimately the decision is made to use one semiconductor or the other. And so I think it benefits everybody here that we give people the ability to come together and work together.
Well, I want to circle back to that in a moment. Let's talk a little bit more about Copilot. So companies like Microsoft and GitHub have made Copilot something of a generic and ubiquitous term. In the context of Flux's platform, what does your Copilot do?
Yeah, great question. So, we have co-opted, the term for electronics design. On a high level, right, you can think of Copilot as on two different axes. On one axis, we're giving people really broad access to Copilot via chat interface, like you're familiar with from, let's say, ChatGPT, but embedded into a design tool, right? And the agent is aware of the schematic it's looking at, of the bill of materials. It has access to all the data sheets in the components, has access to the PCB layout, right? And you can use that for design reviews. You can use that for replacement of components, right? Like get cheaper components, also like explanation tasks, like review tasks. I mean, there's like a huge list of use cases. And what's great about the chat interface is, right, that you can discover use cases on your own, right? Because you have control essentially over the prompt here. But the downside of that is that the quality of the output can vary. It can be incredible, right? Or it can be poor. And so then on the other axis we offer users today is more dialed in workflows. Like I mentioned, right? The datasheet PDF import is like a very dialed in use case we have with incredibly high accuracy and high hit rate, right? And so these two models exist in the platform today.
So about those prompts, I understand that you've recently added vision capability.
Mm-hmm.
And as I understand it, that means that you can upload photos of images, such as block diagrams, to Copilot, and it can recommend parts for your design.
Yeah, absolutely, right? So the Copilot is multimodal, what they call that. So it can not just use text as an input, but also images. And so, yeah, you can scribble with a pen a schematic on a paper napkin, and if it's readable to a human, it's readable to the agent too, usually. But also block diagrams, right? Or whether you take a photo of something, it enables like a huge amount of use cases. Also, think about, right? You have like a power consumption graph or a discharge curve or something like that, right? They can read these curves, right, and help you here with the design questions. Be like, hey, look, I need to implement a noise filter that can generate me that kind of filtering, right? You can upload the chart for that, and it will then be able to help you design an actual circuit, that can implement such filter. So there's tons of use cases like that. And that's, I think, also like the beauty of this like chat-based interface. You can go extremely broad, and it can be helpful in tons of different ways that we haven't dreamt up yet, right? And then users come back with like, hey, look, I tried this thing and it's amazing. Look what it did, right? So that's what's really exciting about it, I think.
And on what basis is that intelligence for the circuit design coming? Have you actually given Copilot samples, actually working designs that you've fed it in order to help develop the intelligence, or is that something that is driven by actual just the users choosing the output and then circling back and somehow there's a feedback loop where Copilot will recognize that, yes, this was a good circuit. This was applicable to that particular design.
Mm-hmm. Yeah, it's a good question. So it depends a little bit on the use case you have, right, and the exact feature used in Flux. But in general, right, we use what they're now called world models that have world knowledge, right? They know everything about what a resistor is up to how to make chocolate brownies. and that sounds like crazy, but if you want to like brainstorm the bill of materials for like a chocolate brownie oven, right, that's going to come in handy that the model actually knows about chocolate brownies, right? So I say that jokingly, but I think there's use here. So you have this world knowledge model, and then on top of that we have like domain knowledge. And domain knowledge is typically, right, I mean, the main data source here is data sheets, for example. It's all the data sheets in our libraries, all the data sheets in your particular project, right, that are leveraged. And then what we started increasingly doing is build a knowledge graph. So for example, say you have like a given Texas Instruments semiconductor and you want to know the actual materials used in the semiconductor. That's information that you typically can't find in a data sheet. But Texas Instruments has that information, right, for a given product category, what materials are being used. And so the data, the knowledge graph we've been building has that kind of associative information. Also like to think about pricing, availability, lead times, end of life information. All this kind of stuff we expose to the model and give access to, so that depending on your use cases and the questions you ask, we have all that information available to the agents, and they can use that to help the user.
So if Copilot is browser-based, where do the information, the data actually reside? Whose server is that on?
Yeah, good question. I mean, Copilot, Flux as a whole is a cloud-based system. So the information is stored and synchronized, in our data centers. And that's also how we enable like the client synchronization, right? If you're working with your team on a project, right, that's also how we synchronize the data between the different clients.
Let's elaborate a bit on how the parts library works. What all does it include? Outlines, footprints, step models?
All of that.
All of that.
You have the symbols, the schematics, the footprints, the 3D models, the simulation models. You have the data sheets, you have the package codes, the manufacturing part numbers, right? We can look up the price, like I said, the lead times earlier, end of life information, right? Compliance information, like is it RoHS compliant, for example. And then via Copilot, really all the information that's in this knowledge graph as I laid it out, in the data sheets, in the associated data is available to the user, within split seconds, right? Just think about, right, trying to figure out what the capabilities of pin 15 on an ESP32 is. Yeah, sure, you can read that 1,000-page ESP32 data sheet, but our Copilot is going to give this information to you in like under a second.
Then how is all that data collected or established? I mean, you mentioned earlier the relationship with Ultra Librarian. Is the data coming from third parties, or is this in some cases supplied by the users themselves?
It's both, right? For like a given user, we leverage all the information they provided in their projects to serve them. And then we also leverage all the publicly available information on Flux to serve them. So in that case, say Ultra Librarian, now provides their whole library on Flux. And that's public, that library on Flux. So all the information is leveraged in your projects too, and for your requests.
So if I'm using Flux, does that mean I could forego using a third-party library?
Oh, yeah, absolutely. Right. Our goal is any component you might want to use is already there. In the meantime, when it isn't, we want to make that extremely easy for you to get it in, which is like why this ability now to like just provide a datasheet PDF and create a component from that is like a feature we invested in and we just shipped, which is really exciting, right? Because there's always going to be that one new component on the market that we might not yet have, and it's going to be a fast and easy way for users to get that.
I want to mention the sponsor of today's podcast is PCB East, the electronics industry's East Coast conference and trade show. Coming in June to the Boston suburbs, this year's event features more than 75 hours of in-depth electronics engineering training, plus a special all-day forum on Ultra HDI design and manufacturing. And attendees for the free expo will see more than 60 leading suppliers of printed circuit design software, materials and fabrication, and assembly equipment and services. Visit pcbeast.com for more information. Matthias, let's talk a bit more about the rest of the platform's features. As you know, where many startups run into headwinds is trying to get past the initial routing obstacles for multi-layer boards and the higher pin counts. So for routing and placement, what is the tool capability now?
Yeah, great question. So we've come a long way here, right? Ultimately, our goal is to support even the most ambitious workloads. Today, where we're at is that you're good up to 1,000 components in a project. And for those who don't know, a good reference here is an iPhone motherboard is 1,400 components. So we're getting close there, not quite there on that end. The other critical capabilities are typically around high density design, flex boards, that kind of stuff, especially if you think about modern consumer electronics. And here too, right, especially this year, we're going to ship a lot of features around, flex boards and high density design. For example, micro vias are going to ship in March now to support those kind of workloads. And so I think in general, right, yeah, whatever your most ambitious workload is, we're aiming to support that within, the next 12 to 24 months.
Got it. So with micro vias, I'm assuming you can do blind and buried vias now.
Oh yeah, absolutely.
What about via and pad?
That too. Via and pad already works actually. That's already supported on the platform. Microvias was still out. What's exciting about the way we approach microvias, for example, is that we place them automatically for you. If your trace requires us to place 3 microvias, then the software will do that automatically. And this is the kind of stuff that we're we want to automate as much as possible of the process while not building black boxes. We want things to be configurable, right? It's the same going back to Copilot, right? We don't want this to be a black box. We want this to be as customizable and transparent to the user as possible, right? And configurable. We want you to be able to put your custom application nodes into the system and leverage those. And same with the PCB layouting, right? We want you to be able, all these little lessons you learned, across the company and across the years, we want you to be able to enshrine that in a design tool so that the design tool can do this automatically. I mean, a good example is we do automated ground copper flots. And that's just because it's become best practice in the industry to do. And you might have some custom requirements around that if you think about the via stitching of the ground planes. But it's all configurable. It's all performed automatically in the tool.
So I'm going to go back to the 40,000 users per month. If I think about who's using this, this is going to go way beyond just one-off users, hobbyists and folks like that. You mentioned semiconductor folks. It sounds like Flux is being used now by serious OEMs doing serious projects. Is that a fair statement?
Oh yeah, absolutely. And not just for serious projects, for themselves or their customers, but also like as a sales and marketing tool, right? We see a lot of like semiconductor manufacturers use, Flux to like share the reference designs for their products, to do customer support and communicate with the customers. Like, hey, if they have a question, right, they can come here. And also to learn about how customers use their products, which is like outside of Flux, it's like a highly manual process where you like at best get very vague information, And so that's really exciting. And I think that's going to like lead to like tighter feedback loops with OEMs, right? And to lead to them being able to support customers better and build, design products that are more tailored to what customers actually need.
With Flux being browser-based, not all browsers, of course, are alike. So what are the requirements? Like which ones can actually handle it?
Yeah, good question. So we support all modern browsers, so Chrome, Safari, Firefox, Microsoft Edge, and then Flux even works on an iPad or iPhone. There's like memory constraints on mobile devices, but in principle, it works.
Matthias, when we talk about semiconductor users, and I don't want to focus too much on that particular aspect or that segment, but it probably gives you a unique perspective about the Renaissance announcement with Altium, and probably see the strategy behind that, maybe more so than a lot of other people would.
I mean, absolutely. I like chuckle a little bit because it's, of course, something that we've been saying for like 5 years now, that there is a change coming and a renaissance coming, and like of the hardware and electronics industry as a whole. And we see that now. I mean, like NVIDIA is now the third most valuable company in the world, more valuable than Google and Amazon. That's something that people even a year ago would have laughed about. And then now we're here. And it just underlines it like, look, yes, software is eating the world, but it's powered by hardware, by semiconductors. We've seen this whole trend to like edge computing, right? Bringing compute back to the edge, away from data centers, right? Especially with like large language models and AI, where like, just think about Apple and Google, right? They want to run the large language model on the actual smartphone for latency reasons, for privacy reasons, for compute cost reasons. And so I think we're just getting started here, frankly. Right? We're going to see large language models like AI in a lot of products. Just think about your robot vacuum at home and how dumb they are today, or your Alexa or Google HomePod or whatever it's called. How like actually compared to like a ChatGPT or a Flux Copilot, how very basic and primitive they are. So there's huge opportunities. And so I think, what we're seeing here right now, we really just day one here. Think about this, like GPT-4 is like barely a year old. It's just the very beginning.
I certainly agree. We're just scratching the surface of where we're going to go. So speaking of scratching the surface, with that number of users, you are probably at some degree of revenue now?
Yeah, we are. Mm-hmm.
Great. Congratulations.
We're projecting to be profitable by end of the year, right?
It's always exciting cashing the checks, isn't it?
Yeah, it is, right? It's like a new chapter in the life cycle of Flux and the company. So it's very exciting, yeah.
Can you talk a little bit about what your pricing model looks like?
Yeah, totally. So we have two different, models at the top level. We have a self-serve offering, which is what you see on the website, which is a freemium subscription model. We have free tiers with some limitations, and then we have tiers for educational users, so students and professors, and then a couple individual paid tiers, and as well as like an organizational tier. An organizational tier is interesting here because if you're an open source or a student organization, then we allow you to use that for free. But if you are, like a private business here that requires privacy, then we have a paid tier for organizations for you. And that's all self-serve. And so that's like, where the bulk of the users is, obviously, right? So like, you have to imagine here, around maybe a quarter of them are hobbyists, another quarter is students, and then the other half is like individuals to SMBs using the platform. And so then next to that, we have the enterprise offering, right? And that's really for your Fortune 500 hardware company, like think NVIDIA or Intel or so. And for them, we have like a little different offering, which is like, giving them like the IT integrations and privacy they need, but the support offering they need, and all that kind of stuff that goes with it. And then also, right, another interesting thing is like just enterprise grade exchange formats. Like think of something like JP30, which is like popular in the Cadence ecosystem, which like you don't find so much at SMBs or really not at all, or individuals who typically come like from Altium or KiCad and not from Allegro. So yeah, these are like the major distinctions here.
We did talk a little bit about Ultra Librarian. Can you go into a little more detail insofar as the integration with other tools? For example, could somebody use a third-party schematic capture and then flow that into Flux Copilot for routing and placement?
Yeah, absolutely. So that's something we're working on, right? To support just import of like a netlist and let's say a bill of materials as a CSV file, so that users can leverage the AI functionality here. Absolutely. And then the other way around too, right? Where like we allow you to manage your library in Flux or your schematics in Flux, and then just export, to file formats like JP30 or ODB++ and so on. I think especially in enterprise, you can imagine that like it's a huge lift for like a Fortune 500 company to switch out all their tooling. And typically where we come in here is like in more on the library management side, because, there isn't any like off the shelf collaborative library management software available in the market today. And especially not if you think about something that's AI powered. And here Flux is like really like an almost over-engineered solution, if I may say so. And if you think about the collaboration and review processes and AI capabilities, right? Just like I said earlier, right? The fact that you can now just take a data sheet, PDF, and upload that, and then within seconds have that create a part for you where you can visually review this now. You can look at the symbol, look at the footprint, collaborate, be like, hey, are we happy with the corner radius here? Do we want the paths a little bit tighter? And then go from there also to like the downstream usage, where like now the engineers at the company who want to use these components can like come back to Copilot and ask questions. That's like an unprecedented toolkit you're giving users here, and so it's very popular with an enterprise.
And you have demos on your website where folks can actually go take a look at how this all comes together.
Yeah, absolutely. And don't hesitate to contact us too, we're doing a webinar, I think this week, and there's more to come. I think we're also looking now at in-person events in major hubs. But yeah, there's also a lot of this you can just also try out, with the publicly available product. So yeah, come on in.
Matthias, before we wrap up, anything else you want to share with our listeners?
Yeah, we're really excited. The way we think about here is like we really want to bring AI first thinking into hardware design. And we're really building this platform to integrate all these hardware features, these AI features into the hardware design pipeline. And it's very exciting, right? I think we're day one here. We're so early in this, and there's so much more to come. And we're really excited about the future.
Well, I tell you, congratulations. You've certainly made a lot of progress here, especially in the last 8 to 10 or 12 months. And it looks like you're on a great trajectory.
Thank you.
Our guest today has been Matthias Wagner of Flux. For those who want to learn more, you can visit flux.ai. Thank you for joining us, and come back anytime, Matthias.
Thank you. Will do.
For PCB Chat, this is Mike Butow. Have a nice day.